Hello there, guys. Today we're going to be looking at hypothesis testing, and we're going to keep this module to a one sample hypothesis test. You can do the same for multiple samples as well as proportions, but like I said, we'll keep it simple. And you'll see that it's pretty straightforward if you think about the logistics behind how this is done. It's always going to be the same steps, so it's very repetitive, and as long as you follow the steps, you should be fine. Now, a hypothesis, just basically a statement, right, about a population parameter. Something about the mean. Maybe we think the mean, we think something to be true about the mean or population proportion, or even as far as the variance. There are different tests you can perform to determine whether or not your statement or your hypothesis is true or it's false or not to be accepted. So hypothesis testing is just a procedure, okay? In terms of the null hypothesis, basically there's a bit of some terminology and some syntax that we deal with. So we call the null hypothesis a statement about the value of the population parameter, what you are going to believe about the population unless you get strong contradictory evidence. The null hypothesis will always contain the equal sign. Okay, well, you'll see what I'm talking about as we move along. The alternative hypothesis is denoted with an H, okay, with a little 1 next to it. This is a statement that is accepted if the null hypothesis is rejected. In other words, it's the opposite of the null hypothesis. We have different types of tests. We have a one-tail versus a two-tail. One-tailed when the alternative hypothesis states something about either a direction. It states direction, okay, greater than, less than. For example, in this case, our null hypothesis, maybe we think the mean income of females is less than or equal to, so it contains the equal sign, to the mean incomes of males. The alternative would be that, well, if we think that this is less than, the opposite would be greater than, but it does not include the equal sign. That's a one-tail example. So we have direction, right? Greater than, less than. Look for those keywords, and that tells you that you have a one-tail situation, and we can perform the test accordingly. Two-tailed tests, basically no direction is indicated. Okay, and so in this case here, you'll see that, for instance, the mean income of females is equal to the mean incomes of males. You can see that we're not saying anything about greater than or less than. So you can see that the null hypothesis is going to have an equal sign, and the opposite of that is that female is the mean income of females is not equal to. So it would have a not equal sign involved. So here are a couple examples. The mean pulse rate is 82 beats per minute. Well, that is really telling us that we think the statement to be true. It is a two-tail, right? Because there is no direction. And if we were to write the two hypotheses, the null hypothesis is showing us that the mean is equal to, right? Remember, the null hypothesis has the equal sign, so it's equal to 82 beats per minute. The flip side, right? The opposite of this is the statement that the alternative hypothesis is the mean is not equal to 82. The next example, the mean life expectancy is to increase from 36 days. This will result in a one-tail, and specifically increase greater than tells you the direction, okay, and you'll see what this means in terms of the picture in a couple minutes. So in terms of the hypotheses, the mean life expectancy is increased from 36 days. So in this case, we can say the mean is less than or equal to 36, and the opposite is the mean is greater than 36. Now, you see that the increase, right, increase greater than, we always have the direction, it's greater than, it's pointing to the right. So in this case, the direction actually is included in the alternative hypothesis. Now, in terms of the different scenarios we can have, suppose we had the situation where our hypothesis is true and the person is innocent. Suppose we're looking at a trial, or it's false and not innocent. And we actually, suppose what we do in our trial, we reject this, even though the person is innocent, we convict the person. We know we've made an error, right? If we convict the person when the person, the suspect, is actually guilty, right? Then we would have made the correct choice. Likewise, the statement is the person's innocent and we acquit. Well, we made the right choice in that case. And if we acquit even though they're not innocent, we've made another error. So in terms of statistics, we have two different types of error. We have a type 1 and a type 2, and we'll get into that in a second. Okay. So in terms of the error, type 1 error is saying we reject the statement, the null hypothesis, when it's actually true. And type 2 is you do not reject. That's reject. Right? H naught when it is false. What we're really interested in is looking at this type 1 error. Okay? So in this case here, the level of significance, okay, is going to be stated, and it's saying the maximum probability of committing this type 1 error. So that's what that really means. I know this is really technical, but like I said, just bear with me, and you'll see how when we get to the different steps, how easy this actually is. The different steps involved, and you'll see that first of all, we start off by stating the different hypotheses. We find the appropriate Z value or T value if we're talking about a small sample. We perform this test. Well, that's just a Z score. We've done this before. And then we make our decision based on our information, and then we state our conclusion. And we state our conclusion based on H1, and you'll see what I'm talking about. Now, this idea of critical region and non-critical region. The critical region is the rejection region. In other words, it's the area that indicates to reject our null hypothesis. All right? Non-critical region, the area that indicates do not reject. And the critical value is the dividing point between the two. And that's your Z value or T value, which I've shown you how to find depending on the level of confidence that we're dealing with. Okay, so when it comes to our Z test, this is what we're going to be dealing with, which is just review, right? We've done this before. And when we look at the picture, okay, of this idea of rejection region and non-rejection region, basically, if we have a situation where there's no direction, we have two tails. We have a tail here and a tail here. If we have either a direction involved, this is going to be either to the right or to the left. In this case, our alternative hypothesis would show that it's greater than, and our alternative hypothesis would state less than. Okay, but what we end up doing is performing the Z test and seeing where does this Z value actually fall. Does it fall here? If it falls in these the non-shaded area, we do not reject the H naught hypothesis, right? The null hypothesis. If it happens to land in any of the shaded areas, then we reject the H naught hypothesis. All right. So there are a handful of examples, and I will go through this with you, okay, step by step. And you'll see it is very monotonous, very organized. But as long as you understand the premise here, what I've just said right there, you'll see that this is pretty straightforward. So here are the examples, okay? And I will ask that you take a look at the other sheet that I've uploaded with notes.